My name is Andrew Yule. I work at a company called Quantum Analytics, where I'm a managing partner and a co-founder. And today I'll be talking about safety log analysis in oil and gas, a multi-stage LLM approach for enhanced hazard identification. So quite the mouthful, and I'll try to break that down a little bit further. Right. So motivation. I'd like to start at a kind of a high level here. If you're like me and like many people, I think you've heard this AI buzz. You've heard all the hype around it, and you've used things like ChatGPT or Gemini or Cloud or whatever the case may be, right? And you've probably used it to enhance some reports or maybe write some emails for you or things like that. But I think by and large, right, I think a lot of us are still trying to figure out where exactly does AI fit, right? And the key thing I think about AI is that fundamentally, right, when we talk about AI, we're talking about LLMs, large language models, and their use is kind of in the name, right? Large language models, right? They're used primarily for things that are related to language, to diagnosing text, understanding text, and things like that. And I think if you keep that in mind, it'll serve you well in terms of where you kind of apply AI. So kind of getting more specific into this talk, something that we're focused on here is analyzing safety logs. So any kind of large industrial process, manufacturing plants, chemical plants. In this case, this is an oil platform out in the North Sea. There's a lot of safety logs that are involved in these things, and they tend to be very regular in terms of how the input must go into them, and there's flexibility on what people write in them. But that often leaves this scenario where you can't get back out the insights that you want from those. And so knowing that these are language centric, they're human written things, it's the perfect case to utilize AI for. And so what we were trying to do with this was really take kind of a boring topic, something like safety logs, and look to see how we can make that interesting, how we can accelerate the hazard surfacing, so understanding what's kind of embedded in these safety logs, and probably most importantly, how can we make them more action driven? How can we give a client, in this case, a customer or someone who's actually operating something, how can we give them more insights into what's going into these safety logs and how that translates into actual safety? So in this talk, I'll walk through kind of a workflow that we did. This is kind of mostly in a proof of concept phase. It'll be moving beyond into subsequent phases here shortly. And what we've done for them is actually build kind of a full, and I'll talk about this, a full kind of data pipeline, a full dashboard on kind of a third-party business intelligence platform. What I'll kind of show here are bits and pieces of that, and what I'll show really is kind of the Wolfram language that was used primarily to kind of prototype a lot of this stuff and how quickly we were able to do some of these things. And so, as I mentioned again, this was for a oil and gas operator in the UK as a platform in the North Sea. So you can imagine a very kind of harsh environment, a lot of safety related things that might be top of mind for them. What we were given was a safety log, an example of their safety log for about the last year. Within that was about 13,000 observations. And so I'll load that in to kind of start and give us an idea of kind of what that looks like, loading it in here as a tabular object. And you can see kind of some of the columns that we're dealing with. So we have things like the title, the case number, the date and the time. Important ones would be kind of the observation. So what did the person see? What are they recording in the safety log? What was the action that they took? And then there's some standardization related things like the category. And these are within how this information gets into the log. This is kind of a drop down. So these are pre-populated things that they can put in there and say it falls under kind of a certain category. Just to kind of give you a very specific example of what one of these looks like. So there's a title here, insufficient lighting. There's an observation that says the person writing this is saying, while carrying out light PMs and a blah, 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 we were unable to carry out the repair of a lighting fixture. Right? And it goes on and it talks about what the action taken was. And then there's some of these categories that I say, like this was a This is a safe tag. This is personal safety. There's related to personal safety and access, egress, right? Things like that. So there's a lot of information in there, but as you can see in its kind of raw form, it's not all that usable. And there's, prior to kind of the age of AI, getting the value and extracting the insights from this would be really challenging. So I'll start with just some really basic kind of exploratory analysis. This is showing the number of entries in that safety log over the time period that we saw. It's again about 13,000 entries. We're averaging somewhere around between 1,000 to 1,200 entries each month. A little dip down here, and then it kind of goes back up. But getting to kind of the heart of the issue, what I was mentioning before. So there's these drop downs in the safety log that say, please give us a categorization. And the drop downs that are available, it says safe act, unsafe condition, unsafe act. And those are helpful. They certainly kind of give some indication of where to start or how severe this kind of thing was. But probably leaves a lot to be desired at the same time. And there's some more kind of information in here. There's this attribute in here called a checklist. This has maybe some more specifics. But again, these are very like high level things, hard to kind of piece some of these together as you look through them, and really not all that descriptive. So what we built at a high level is kind of an end-to-end solution, and within it there's really two workflows, and I'll focus on those during this talk. The first one is taking all these observations and basically assigning a better category to them, something that's reflective of what the client, what the operator in this case truly cares about, and right along with that, giving kind of a priority score. So saying, what was the ranking, a numerical ranking as far as the security or the safety concerns associated with that. And then the second part in that dual workflow is looking at the action that was taken by someone and then comparing that to what a ideal action would be, and coming up with some kind of ranking or some kind of way to say, hey, when we see these safety concerns, how appropriately are we acting on them? Are we doing things that are right, or is there possibly a lot of improvement to make in that area? So this is a screenshot of kind of the final dashboard that we created. Again, I won't talk too much about this final stuff. I'm really trying to break this down into smaller, bite-sized examples that we can quickly understand here in this 20-minute talk. But this was the larger data pipeline that we've set up. So there's this ingestion phase where these observations come in via CSV file. There's a cleaning, there's an embedding stage. We're looking at that similarity, doing LLM scoring. In future phases, there will be a retrieval augmented generation actioning portion of it. And then finally, all this is feeding into a dashboard. But let's kind of break these down. So of the two workflows that I mentioned, so workflow one, and then within that kind of the first one, right? So what we set out to do here was understand there's a better way to categorize these observations that we're seeing. And certainly this is something that could be a drop down, something that people could kind of flag themselves. But in that case, you're at the mercy of, did the person kind of pick the right thing? Did they truly assign it to the best one? And one of the best things we can do is just look at the information ourselves and use kind of our own AI related technology to basically classify that ourselves after the fact. So to kind of walk through that, what I'm showing here is a function within Wolfram language called semantic ranking. And what this is doing, if I kind of expand this, is I'm giving a list of different categories that we care about. And these were discussed with the operator in this case to come up with these 7 things that we care about: safety and risk management. Is it equipment and asset integrity? Is it process operations, et cetera, et cetera? What I'm doing is I'm writing down that hey, this is a particular category. What this covers is physical and process safety, hazard identification, and I'm giving some information about what I want it to find that would ultimately lead to it being classified as a safety or risk management item. And then we put this into the semantic ranking. Here I'm creating a function that does that, but what I'm passing in is the observation, and I'm saying, please find from this observation, from what the person wrote in this observation, please find the closest of these 7 categories so that I can correctly assign it. So kind of evaluate that. and then here I'm creating a new column in my tabular object, and I'm saying please give me that category. In this case, I'm just going to do it for the first 5 so that we don't sit here. But you can see it's come back with something. It says, okay, I think of these first 5, it looks like 3 are equipment and asset integrity. 2 in here are safety and risk management. So again, right away, and I'll kind of evaluate here. I have a saved version of this with everything, but right away, right, we're going from what was provided in terms of a drop down in these safety logs, kind of uninformative really, to something like this, where we can clearly see kind of a better breakdown of what is safety and risk management related, what is equipment and asset integrity related, and so on and so forth, and we can see proportionally where these start to line up. And once we have that, the next thing we wanted to look at is say, okay, well, now also please read that observation again that someone wrote. And this time I'm using something called a template object. And I'll evaluate it this way. I'm giving an LLM a big prompt, and I'm saying, essentially you are a safety observation score assistant. And I want it to come up with a number of how kind of problematic, how unsafe it thinks it is. It thinks the observation that was provided was, right? So we can see these kind of rankings 0 to 10, all the way up to 91 to 100, which is critically unsafe, urgent response required, and things like that. And then I'm passing in this example to say, please kind of use this as an example, and now do the same thing on your own, right? And I'm using, in this case, LLM synthesize along with this template. So we can kind of do a quick example here of, oh, I noticed the door was open that is only automatically closes. So I'll evaluate that, and we'll see if this works in real time. Right, so it says, come back, and it said, okay, I think this is kind of a priority score of 25, and just for comparison, what if I say, well, I dropped a hammer from the top floor? Okay, so clearly it thinks that's a much more dangerous thing. It's up at 85, and now what if I say I dropped a hammer from the top floor and it hit somebody? Right, now we're all the way to 95. Arguably that should be 100, right? But we're in the right zone, right? So it's picking up on what the observation was and giving it a correct kind of ranking from that. So again, we can take our tabular object here. We can kind of apply the same thing across all these observations, and we can begin to understand not just the category of what was, the observation was really related to, but we kind of end up with these priority scores for how unsafe it actually was. And I've got kind of more of these here. I won't let that LLM run all the time, so I've kind of just pre-populating that. But we can get a sense of, where do we line up in terms of how risky are the things that are being logged in this safety log? How unsafe are they actually? And this is things that you can never get, right? You can't necessarily ask somebody to assign this ranking themselves. You'll end up with all kinds of bias. Certain people will think some things are more severe than they maybe are, or vice versa. But here you get kind of a systematic way to understand how risky some of this stuff, some of these incidents are. And if we kind of just pull, for example, this, what did it find as the highest? In this case, like a 90. What was the observation that led to that? It said fire exit and smokers on level 5 did not open during the muster. So to me, that is a fairly critical thing, right? I think it's certainly not necessarily leading directly to an accident, but very likely could. So that brings us to workflow 2. So the second thing that we're essentially trying to do here is we're going to look now, instead of just at the observation of what someone reported, they also have the ability to write in the action that they took. So again, we want to apply that same concept, and we're kind of pre-populating the LLM with a prompt here and saying, again, you're a safety advisor and you're being tasked with determining the action that was taken. Please use all the safety knowledge you have and provide the immediate action that the individual should have taken. So it's going to read that observation and it's going to say, based on what you know about safety and whatever you've been trained on, please come up with an action that you would have taken. And so if we set up a function to do that, we can kind of test that this is working and say, I noticed that a door again was open that normally closes automatically. We can see what the LLM, just based on its own training knowledge or whatever, would come up with, and it would say, ensure that the door is closed to restore safety protocols if applicable, investigate the reason, et cetera, right? Obviously, this does not necessarily take into account the particular operator's own unique safety guidelines, right? And so I think this kind of, as this project for us moves from the proof of concept phase into subsequent phases, what we'll actually be doing is, instead of relying on an LLM's just trained and default answers to how to address a safety concern, we'll use the techniques of retrieval augmented generation to actually build in the company's safety guidelines and their recommendations to the furthest extent possible, so that when the LLM is making a recommendation, it's relying on that information instead of whatever mass kind of information that it might have been trained on. And then the second part, again, of this workflow too, is to kind of understand, okay, we have a recommended action from an LLM. We've been trained on company guidelines ultimately, but what action was taken? Can we come up with some kind of quantitative way of comparing those to understand whether we're addressing safety concerns in the most optimal manner possible? And so to do that, essentially what we're using is we're extracting we're taking the text from what the LLM produces versus what actually happened, right? So for example, if the actual said, okay, well, I stopped my process, and I reported, what they're saying is they reported to their production supervisor until instruments could be investigated, right? And that same, in this case, the LLM, let's see, we can see what it would come up with in terms of its recommendation, right? So it would say immediately halt the operation, notify the control room supervisor, which is actually very much aligned. And what we can do is we can essentially turn both of those two responses into numerical vectors, kind of by using embeddings. And Wolfram has come out with a sentence vector way of doing a feature extraction. And what we can do is we can take the cosine similarity from that. So that gives us a numerical quantity now that allows us to basically compare these two, the actual to the recommended, using some kind of semantic, reference points. And we can assign a number, and we can say, well, this was how kind of close the actual was to the recommended. And just for comparison purposes here, right? If they had written in here that they did nothing to address this safety concern, we can see here, well, this should actually probably be even smaller of a number, maybe a negative number, but you can see that there's a difference that we're able to quantify between what actually happened in a bad case versus what happened in a better case, so to speak. So that's kind of the gist of it. Walk through the two workflows and the two kind of sub areas within each of those workflows. As I mentioned, like this is really part of a broader project for us, and a lot more going on here. And I wanted to just break it down into the essence of what we were doing, right? The bigger project, right? As I mentioned, it has kind of this automated data ingestion, so it's getting this live stream from the safety logs in the CSV format. It's doing this semantic understanding. It's also then kind of ultimately it will be AI powered, but we will build in some of that retrieval augmented generation utilizing the company's own safety guidelines and recommendations to kind of make it as smart as it can and as relevant to the operator as possible. And then we built in some of this quantitative priority scoring and quantitative action scoring to kind of give numbers and charts and things like that we can look at and extract as much value as we can from the safety log. And then of course for the end user of this, this is a scenario where continuous learning is capable, right? People can use this information, use these kind of dashboards to understand where there are gaps, where there are safety concerns, and ultimately how they can improve going forward. So, as I mentioned at the beginning, I think we're taking kind of a very boring topic here, safety logs, but safety logs are important, and a lot of companies have them, and I think there's a lot of value that AI can unlock within those types of logs, which are very text centric, very language heavy. So that's really the end goal, and that's what we're trying to accomplish here. with that, I will stop and I can take any questions if there are any. Sabrina asks, what's been your favorite Wolfram feature released recently? I am a big fan of almost everything machine learning. So I love when kind of the new machine learning functions are coming out. I like the new plot fit functions that automatically apply some of the linear or exponential models or things like that to your plots. That's something that I've always kind of wanted as a really quick way to do those kinds of things. So there's probably that, and then I think probably some of this LLM functionality as well. I think it's really neat how they've integrated that so quickly and efficiently into the language. So one more question. Danny is asking, how many companies are you working on with this? Is it easy to move from one company to another? Yeah, I think this is very. This is for one company in particular. We've certainly talked to a lot of other companies about it and gaining interest there. But I think it moves very easily from one company to another, right? I think again with these logs being so text centric, AI LLMs have basically unlocked a lot with that, and it becomes very easy to move this functionality around for sure. All right. Well, again, thank you all for attending, and hope you have a great rest of the conference.